All right, hello, I'm Marco. Come from Italy, I live in Germany, and yeah, I do a lot of talking and so on. I'm known on the internet as Akramius. My main job is being a troll on the internet, and sometimes I do actually some development. This is my avatar for those who don't recognize nicknames and the names. But I had to upgrade it because they started calling me Gandalf PHP because I do some really ugly things with PHP, so I did an upgrade. All right, I work for a company called Rove. We are consultants, so we come to your company, take a lot of money, and then waste it on conferences. I'm part of the Zen Framework team. I help maintaining the framework and reviewing your stuff and getting things rejected. Sorry, I'm not. I'm trying to be helpful, though. And I'm part of the doctrine team, so we build the ORM. This talk is extremely defensive PHP. It's called extremely defensive PHP because I'm an extremist when it comes to code. I'm not gonna blow myself up, okay? I'm an extremist when it comes to code. And I became an extremist. I've not been an extremist all the time. I did my fair share of mistakes as well. Been doing software for 16 years now or something. But the problem is that I maintain way too much too many pieces of software, and everyone always opens a new issue. Why does your thing not also do this and also do that? Okay, and that is what you get into when you maintain a lot of software. So this is usually done by what we call feature creeps. Every one of us is a feature creep. Everyone wants software to do more. So this talk is about aggressive practices, and I am going to be quite fast because I have very little time. So if you have any questions, please come and talk to me later. Don't be shy. I don't care if you don't know English that well. Just come to me, talk to me. I'm out here during the entire conference. So these practices don't apply to everyone, but they apply to long-lived projects. So if your project is not like 1 week and then it dies, if it's something that needs to live for years, then please apply them. And this applies to every open source software, because if it is out there, somebody will use it. Okay, somebody will love you or hate you because of what you wrote. So know your limits. This is not for everyone. But if you don't like these practices, don't apply them, but I don't see a reason not to do that. But please be very considerate about what you publish. Just because you wrote it doesn't mean that it needs to be out there. It's like the pictures you take. You don't put them all on Twitter, okay? So let's start in a very bold way. You are dumb. No, wait, that is wrong. Okay, sorry, I didn't mean you. Sorry, I am dumb. We are dumb. All of us are dumb, so everyone is dumb. Everyone gets a dumb. And those who don't admit it are the dumbest. And that is because we are animals. We have a brain that has a limited capacity. As humans, we can keep track of 7 things at a time at most, and that is our physical limit. And when you are doing 7 things at the same time, I can tell you it's going to be really confusing. Try bungee jumping and writing software. It's not going to work. Okay, so does anybody know what defensive driving is? I've seen how people drive here. Probably not. Okay, so defensive driving is the idea that when you drive, regardless how careful you drive, others are going to be doing mistakes. There's always going to be the idiot passing with the red light. There's always going to be the little kid throwing the ball in the middle of the street, or whatever. There's always going to be something. Defensive coding is pretty much like defensive driving. So you write the software assuming that it's not you doing the mistakes, but it's somebody that will use your software that will do the mistakes. So you need to be very cautious, not about just the code you're writing, but about everyone's code, the code that depends on your code as well. And this includes your own code, because what you wrote yesterday, and what you're writing tomorrow is not what you're writing right now. You are a different person in your past and in your future. It's not you right now. You need to think about your future self and your past self. Okay, I'm not talking about new stuff here. All these things exist since years and years before I even started coding, okay? And we are talking about concepts that come mainly from these 2 books. One is Code Complete, which is a really good book, but it's a bit outdated. So this book is like containing rules like functions should not have more than 50 lines of code. And I'm like, maybe 5 lines of code, okay? So it's a bit outdated. And then this other book, this is amazing. This book here is a manual of how to build bugs in Java, okay? And this contains all the possible things that can go wrong in Java. It contains bugs in concurrency threading, in input-output, in shared pointers, null pointers, whatever. Other things that are really, really common are pokayoke. Pokayoke is a concept. Anybody heard of this before? Yeah, a couple hands up. Pokayoke is, in Japanese, means foolproofing and avoiding mistakes. Now, I hope nobody knows Japanese, because I'm fairly sure that I'm saying bullshit here. But the idea is very simple. It comes from the industrial world. When you build something or you prepare something to be built, you need to reduce mistakes done by the operator or the user. So you build it in such a way that it is really hard to make mistakes. It's like IKEA, okay? They're going to give you 3 different kinds of screws because they fit in different places. They're not going to give you the same screws for everything because you're going to do a mess. Anybody know this? This is an RJ45 cable, right? Everyone know this. Anybody who managed to plug this in upside down? Yes, yes, congratulations, nice. All right, now, I don't want to know how you did this, but this is a pretty decent design. So you have only one way of plugging this in, and it also sticks, it doesn't come out. So in theory, it's a good design. Then it breaks every time, but whatever. This is pokayoke. This is what the idea of pokayoke is. You build it so that it can only be used in one way. Or if you're a system administrator and they fire you, then you make a network killer and you destroy the network. Anyway, this other thing, this is a device that doesn't really follow pokayoke. It exists in a 4-dimensional space, so you plug it in, doesn't work, turn it upside down, plug it in, doesn't work. Then you turn it upside down again, then there is some time warp space lock that I don't know, quantum physics, and then it suddenly works. So this is probably not such a good idea of pokayoke design. Other concepts that need to be clear. Code is reusable. Everyone agree? Yeah? Nodding? Nope. Code is not reusable. Code is crap, okay? If you don't know crap is shit, okay? Code is shit. Once you wrote it, you had your idea in your brain, it's perfect, okay? This is exactly what I want. Once you wrote it, it's not what you wanted. And it's always like that. 90% of everything is crap. And if it is not crap now, it's going to be crap in 5 years. Okay? Your super amazing framework that you wrote in 2007, Zen Framework 1, is crap nowadays. Who uses Zen Framework 1 nowadays for a new project, right? Seriously, I mean, I worked with it, I liked it, but it's outdated now. Abstractions are what is reusable. An abstraction, at least in the object-oriented world, for us, is what we call an interface. An abstraction is what is reusable. You have a specification of how something works, and you will reuse it. So please don't write code, because code is crap. That's the first thing you need to do when designing code. You need to make it as small as possible and only focused on the single thing that you want to solve. So you need to code for your use case scenario and not for your reuse case scenario. When you start building a system, you don't need to build a system that solves every problem in the universe. You just need to get to the problem that makes money, and then you solve the other problems later. But first get to the money. That's the idea. If you have money to waste, then I don't know. Why are you doing software anyway? All right. Okay, so this is pretty theoretical. Now let's switch to some more practical stuff, specifically around PHP. I'm going to assume 2 things, and these are big assumptions. I'm going to assume that you already know what solid code is. Who was here at previous conferences? Okay. Not so many. How many are here for the first time? That's a lot of people. Okay, so I'm going to assume solid code, but please, if you don't know what solid means in terms of software development in object-oriented programming, please look it up. And I'm going to assume another thing, which is that you know some object calisthenics. Object calisthenics is a set of rules about very strict ways of coding, and you should at least learn them. There are other talks about that, but I'm not going to talk about them. Please look it up. First of all, we have these things that are entities, and we keep modifying data and so on and so forth. Try striving for more immutable state inside your applications. What causes bugs in your application is mostly some state that changes over time, and you need to figure out when and what is what. And that when, at the beginning, is what makes it so difficult, right? Every time you make something immutable, you create it and you can never change it, you remove that when. It just was created, okay? It does never change. And you reduce a lot of cognitive load, because that when is basically what you want to look for when you start the debugger. When you don't have that when, then you don't need the debugger anymore. For example, PSR7 got this right. PSR7 is a standard for HTTP requests. It's not fully immutable, but it kind of got there, and it's quite okay. Immutable code can be a bit less performant, but there will be a talk about profiling after this one. So I suggest you go see that. Basically, when you have a problem about performance, don't say, oh, I'm not writing code like that because it's going to be slow, but please profile. Profiling code is how you figure out if code is fast or slow. And some analysis up front if you have been doing some software engineering. But basically, performance problems apply to problems that are bigger than O log n. So anything that is a quick sort, a sorting algorithm, a lookup, whatever is bigger than just a single hit. When you got a single hit, you can make it slow. Nobody cares. You just cache it. Since we made objects immutable, we get rid of setters. Setters do not mean anything in software development when you talk about object-oriented programming. In the original definition of object-oriented programming, Alan Kay's idea was that you have these objects and they talk to each other. They don't tell you, you become this. They tell each other, you do this. Okay? And they tell each other what to do, but they don't pass around state. You don't copy information from one side to the other. That's stupid. That doesn't make anything. So they don't really mean anything, so get rid of them. Try to code interactions instead of state mutations. This means that when you get rid of the setter, at least for when it comes to data and when it comes to services, the only injection point becomes the constructor. You can make named constructors eventually, but basically once you have your instance, you don't mutate it anymore. And this simplifies things massively. So you don't have uninitialized properties. You don't have something like database connection is null, okay, and then somewhere later it becomes something. This is complicated. It gets messy. So you get rid of this idea of optional dependencies. There are no optional dependencies. Optional dependencies do not exist. You either depend on something or you don't. But it's not like in between. So this is a very common scenario. I think everyone coded it. So you have a DB connection object. It has a constructor. And then you have a set logger. You see, we have a setter, so I'm going against the first rule already. But basically, you set a logger, and the logger is by default null. And then what happens is that inside this DB connection object somewhere, the fact that the logger is set or not will change the behavior of the DB connection. This is very complicated to handle. It adds complexity to your tests, to your class overall, and to be honest, it makes life harder also for eventual branch optimization. So dependencies are not optional. They are either there or they are not, period. So what you do is you get rid of it. You get rid of this null inside your DB connection object. Instead, you enforce that a logger is always required. And when you want to not log stuff, you just pass in a new fake logger, okay, that logs to dev null. Dev null is web scale, so DB connection gets super fast. All right. So we got rid of setters. We got rid of mutable state as much as possible. The constructor is the only injection point. Now, the next thing you need to do is you need to get rid of pretty much any public API that is not strictly required. So if you find a way to make the same method, all right, work with less method calls, the same interaction, work with less method calls, remove methods, aggregate them, make a single method that does multiple things rather than splitting out and reusing methods. So you can find a different way, and that's the problem, because a public method is pretty much like a child. Once you wrote it, you have to maintain it for the rest of your life. Or you make a major version bump and you kill it. But you don't do that with children, right? So please be very considerate about public methods, because once you wrote them, people are going to rely on them, and you're going to have to maintain them. And if you drop them, then people will be angry, and they will come with pitchforks and say, why? You maintainer, you are evil. All right? Get rid of logic switch parameters. If a public API changes completely behavior depending on a flag, then this is usually something that is intrinsic meaning of that API that is not exposed in a very clear way. Here's an example. There is a class spammer, which is illegal by default, by the way. So we can spam somebody. We send him, well, we send to this email, we render this template, and we decide whether we want to render the opt-out link or not. Okay, so the intent there is that we pass in this flag to decide whether there is going to be an opt-out or not workflow, which is a lot of logic behind the scenes. So what you do is, instead of doing that parameterization, you just split it. You have a spammer, you send some illegal spam, it doesn't have an opt-out, and then you send some apparently legal spam, because it's still spam. And this one will have the opt-out link. Okay, so you split the methods, remove flags, get rid of them. Flags are just hidden API that you're not exposing as API through an abstraction. Other things that are really important. All states should be encapsulated. This means that when you expose any state, this state must be controlled by your object and not by other objects interacting with your objects. Here's a typical scenario. This is a very common bug that actually is really, really hard to debug, and that is because we are talking about a mutable API. So we have a bank account. I have a setter here. Forget that it's a setter for a moment. We can say refresh with a date time, for example. And this sets the last refresh time. Now, what we do is we create bank account 1 and bank account 2, and we set the last refresh to a current time. Right? Then some stuff happens, okay? And then on the other side of the application, like 20 minutes later, I don't know, then you have something like this going on. Current time, set timestamp, some timestamp. And suddenly what happens is that you have a bug via what we call a spooky action at a distance, because this thing mutated two objects on the other side of the world. Okay, they had nothing to do with your logic. And these bugs are terrible to debug. You're going to figure them out later, and you're going to say, oh my god, why am I so dumb? What did I do there? So what you do is you simply get rid of them by dereferencing anything. So what you do is you clone a parameter here, or you use an immutable instance here. If you use an immutable reference, then you're pretty much safe. Other things that can happen is the same thing with a constructor. So you're not safe there. You should dereference there as well. So you have your clone call here. Okay? And if your objects are mutable and they have multiple levels of state, then you should use something like a deep copy tool. Okay? All right. Any external access also includes subclasses. A subclass is pretty much another use case scenario. So you wrote your class to solve a problem, then somebody writes a subclass to solve a different problem. Now you can't change the original problem anymore because somebody depends on it. Okay, so if there is a bug in the parent problem, in the child problem you're going to have an issue if somebody changes the original problem. So please make states private. Don't allow people to access properties unless there is a strong reason to do that. If you use inheritance, then any child class should not rely on internal components of the parent class, or else you have a mess. Because there is no reliance on a stable API, it's private API, or protected API, and there is no guarantee about it. It's code, it's not an abstraction. So please make properties by default private, right? And keep them like that. There is pretty much never a reason to make a property protected. So please be very considerate when you make something protected. All right. Other things that are interesting. A public method on an object is pretty much like a transaction, because that public method call is going to alter the internal state of your object and is responsible for keeping it consistent. Here's a scenario. We have a public function add money here, and a public function mark bill paid with money. So we have a bill object and a money amount. And then somewhere in a controller, service layer, command handler, whatever architecture you use, you have two method calls, add the money and then mark the bill paid with money. Now, what happens if this call succeeds and this one fails, right? Then your bank account object is going to be in an inconsistent state. And you will have to do some kind of weird trickery with rollbacks and stuff, which is what databases do for us. So we got spoiled by this idea that the database will solve it for us. But you still have an object in memory that is inconsistent. If you're recovering from an exception and you're still using that object, you're going to have a problem. So what we do is we make these methods private. So we have an add money and a mark bill paid with money. We make them private, and then we define a third method called the pay bill. And this pay bill is responsible for restoring any state should there be an exception. So if I expect this method to eventually cause a failure, then I can recover the state and I can restore the current money. Otherwise, you got the money and then you run. Right? So it's actually even simpler. It exposes intent in a better way. This is what I was talking about, reducing public API surface. Right. Do not assume method idempotence, can't pronounce it. English people can't pronounce it either, I asked them. So, okay, so this is very common. You got a controller somewhere, and then you got a request object that you can ask to your controller, and then you want to get some parameters from this request object. So the problem here is that we are assuming that these two calls, this request call, will return the same thing over multiple calls. We can do that for an immutable API, but it's not guaranteed to return the same thing over and over multiple calls. So what you should do instead is you just cache it in a local variable here, right? So you get the thing, and then you reuse that single API multiple times. And this is very important for anything that is time-based API and that has time coupling. Because if you have something like a clock object producing different clock entries over different calls, then you have a problem there, and you're going to have a hidden bug somewhere. And to be honest, it's just one line of code more. And this is actually even more efficient because you're not calling the API twice. All right? So we are removing one assumption. Assumptions in software are bad. Assumptions are what causes bugs, and what causes bugs that actually make you lose money. Assertions. So since we don't trust values, we don't assume that the value that we are given will be valid, anything that is going to be from an outer scope, so in a lower level of protection to an inner scope, higher level of protection, so for example from application layer to domain layer, has to be validated strictly. And you need to throw exception, it needs to crash. Anything that goes from outer layers to inner layers and is invalid must cause your application to stop execution, or at least throw an exception or something like that. So you need to enforce very strict invariance anytime you have this kind of movement, data flowing from outside versus inner parts of your application. Here's an example. So since PHP doesn't have variadics, it is impossible for us to define that this array that we get here must be an array of wagons. So when we build a train has wagons. It doesn't have potatoes, okay? It has wagons. I've seen trains that are potato, but... Anyway, so what you do is here, in this case, is you pretty much use this weird trick where you splat, you explode the array via the splat operator, and then here you pretty much use the same splat operator to assert that these wagons are actual wagon instances. Now, this is a horrible hack, and this is just because I wanted to make a slide with some complicated code so that everyone can get confused. But it works if you're on PHP 7. Please don't use PHP 5. Right? There are libraries that do this, so you don't need to invent it yourself. And these libraries will also throw very meaningful exceptions. So they will actually tell you some message instead of a fatal error somewhere. So just use them. There is this one. There is one by Web Mozart, Bernard Schusek, the guy that built this Symfony form component. And these are really, really important. Put assertions everywhere. You do not trust a value fully. Do not expect, therefore, mixed parameters. So avoid mixed parameters, because mixed parameters means that you have a lot of assertions there, and your application has a weak spot. This is one location where your application may crash. Plus, that @param mixed is pretty much like showing the middle finger to the consumers of your API. Okay? When you see mixed, that's pretty much like middle finger. You can replace it with an emoticon or something. @param middle finger. Anyway, so you got stuff like this. This is one of my happy examples. It's a prisoner transfer request. It's something that happens in an organically grown API. So what happens is that you have an access level for the transfer. You can approve it with a security level, and the security level probably was just false or true initially. And then over the years, it became false, then true, then null if it's to be decided, and 10 is special cargo, 20 is high security. This is typical in software that has grown without redesigning and refactoring over time. And it's a WTF barbecue. This is impossible to maintain. Don't do this. So what you do is you take this security level thing, which is a big blob of business rules that are implicit and middle-fingered, and you move them to a value object. Value object which is a prisoner security level, whatever. But now this thing encapsulates these rules. You now define what kind of things are allowed or not. And you can type hint against it, and you can trust it because you wrote the rules around it. So value objects are a really, really powerful way of communicating inside your application because you don't need to revalidate in every layer. They simplify things. They ensure consistency of your data, and you can trust them because you wrote them. You don't trust value objects written by others, please. Don't import a value object from an external project and use it. You need to have written them yourself. They need to be under your control in your domain logic. So you simplify basic data validation. A value is consistent against a set of rules, and it exists on its own, and that's how you define it. So when you create a new register API somewhere and you pass in a value object that is an email address, you trust the value object to pass you in an email address and not some random garbage string. So you don't need to revalidate in register or in all the other layers. The type system does it for you. Even if we have a very weak type system, it does it for you. The same goes for mixed return types. Every time you code an API and you say mixed as return, you are saying to the person that is going to use your API, it's your shit now, okay? Anyway, don't do that. Please type hint, return a value object, return a string, an integer, a boolean. Use stricter APIs, but don't use mixed. Mixed is really, really terrible. Even array is also terrible. If you have an array of things, you return a value object that represents an array of things. You don't just return an array, because it makes it complicated for the consumer if that array actually doesn't contain what you expect, because you're putting a level of trust every time the type system doesn't do it for you. So, value objects again, return value objects. They make it simpler. All right, so I'm going to speed up here. Avoid fluent interfaces. So here's an example. This is a fluent interface. All these 3 ways of writing this code are valid. They're working exactly the same. They will do the same thing. Now, the problem here is that this doesn't follow Pokayoke. we talked about it, only one way of doing it. There is no need to have 3 ways of doing this thing. This one works perfectly fine. There is no need to use a Fluent interface. Yes, it reads like this, but at least you don't have 3 ways of messing it up. I was saying something else. But there's blog posts for that. I have massive rants that I wrote about it. Other things that you should do. I said a subclass is a scenario where you have a different use case solved by the implementation of the parent class plus some subclassing. This means that you have an additional scenario that you're trying to solve, that you're trying to work around. Now, if you make a class final, you define that every time you have a new problem, the person coming next will simply have to solve his problem in his own way, which is much better because he's going to hit the spot and solve that problem only for what he needs, and not inherit some weird logic that you wrote, and maybe you were thinking something else when you wrote it. So, every time you have an extension, you have a different use case. It's a different API. It's something different. So, what I take as a rule of thumb, when you need to think about whether you want to use the extends keyword or not, what you can do is simply take the class that you want to extend, strip it from all the contents and let it only API, make it an interface, and now think about it. Does it make sense to extend this interface? Does my sub-interface add some meaning to what I'm doing here? Is there some additional semantic meaning? If there is no semantic meaning being added, then inheritance is not the solution to your problem. All right? If it is, then okay. But please design for inheritance when you are doing inheritance. Don't make it allowed for everyone to inherit from your stuff. If your API is not designed for inheritance, don't use inheritance. Very simple. Traits. Who uses traits? Ha ha ha. Nope. Nope. So, as I was saying before, code is crap. Code is not reusable. Because code needs to be rewritten and changed, whereas abstractions need to be stable. And when you change an abstraction, you're going to have a BC break and whatever. Now, what you do with a trait is that you have a piece of code, and your compiler copy-pastes that code to 20, 30, 40 different classes. Now, you change that trait, and how do you know that one of those classes will not break because it was assuming that the code did something, and now it's doing a slightly different thing? And now every customer that you have is automatically deleted because of whatever. Right? This can happen, so don't do that. Do you really need to reuse that code? If yes, okay, but you need to have a strong use case scenario. Right? So please avoid them if possible. Don't repeat yourself. The concept here is just adding some hidden coupling, and you're not really saving any time. If your problem as software developer is the speed at which you are writing software, then you have a problem, because the problem should be the speed at which you design software. If your problem is typing on a computer faster, then why are you not a typist and not? You should be software designers. If you're typing a lot of code to solve a problem, then you're probably doing the wrong thing anyway. So, other things you should do. Ensure some deep cloning. So anything you copy should be deep cloned, because cloning is an operation that assumes that you know the internal state of your objects. And this is an operation that goes to the heart of your API. It breaks encapsulation. And you have bugs about dereferencing and all this stuff. So, you need to understand the internals of the object and not the API. So when you clone, you're not using the API of the object, you're copying the state of the object, which is kind of a contradiction. This is a problem. So please, maybe, disable cloning. Disable cloning, which means doing something like this. You have a human, and when you clone, it throws a domain exception. It says, why would you clone me? It's currently illegal. It may be legal sometime. I don't know. But you can also just make it private, and it will throw an exception. Same for serialization. Serialization is making everything inside your objects serialized to some format. Now, some objects support that. Anybody tried to serialize a PDO exception and got a failure? Yeah? Because it doesn't make sense. You can't put a connection in a string, put it in a different server, and it works again. That's not how a connection works, right? So is your object really serializable? Right? Do you know the life cycle of every component of your object? Yes, no, you know. If you do, then okay. But is your object even supposed to be stored in a string? Right? You don't know that. Some things are highly mutable and you can't do that. So disable it here as well, maybe. Or use serialize only on things that are actually serializable. Okay, last thing, unit testing. I just want to say that you need to unit test every scenario. So if you're from the old school where you do branch coverage, that's probably okay. I'll skip on it, I just don't have time. So we have an out interface, out service, returns a Boolean, throws 3 possible exceptions, all right? And we depend on it because we have an API which is called myLogin, depends on the out service, has a function login that uses the authenticate method with some credentials, returns either true or false. Does anybody know how many tests you have to write for this? 5? That was good, that was fast. You need to write at least 5, because you have 2 scenarios here, 3 scenarios here. You need to assert on these exceptions, okay? You need to assert that they get thrown or bubble up, depending on whether you handle them or not. Plus, you may have exceptions here if the values are invalid in that value object. So you see that if you pass in the value object here, instead of constructing it here, it gets simpler, because you remove a validation concern. So, skipping on this, to recap, all of these are just suggestions. You don't need to apply them. Please do, though. That's my suggestion, at least. You do not trust any code, not your code, not code from your colleagues. Please review code. Please do not trust that it will work as it advertises, unless there is an interface for it. Keep features to a minimum. If you write code, don't solve a problem that comes up in a year. Solve the problem that comes up the next week, and solve it in a way that makes it easy to replace your code. Okay? Do not write something that causes high coupling and you will have to be stuck with it for a year. You ain't gonna need it. If you write a feature that is not yet ready, then you probably are also misunderstanding a feature. You want to depend on strict invariance, so the data that you accept is very strictly verified, and you want to await that, and you want to return that. So please use value objects for these. Thank you very much.